So IY is 15%. Okay, so full-fledged, I'll just do Macaulay duration again, modified duration, and all that related to this, so that in one go you will get all. Okay, IY is 15%. Then future value is 100. Present value they have directly given here 86.59. You can cross check also. Is it matching? Based on this information, check.
Yes, sir, it's 86.5.
Okay. Now Macaulay duration, let me calculate. So Macaulay duration is equal to, Macaulay duration is equal to present value of individual cash flow divided by present value of total cash flow. Okay, into number of periods of payment. Okay. So present value. So 5 years. 1, 2, 3, 4, 5. And how much is the coupon? 11, right? 11. So 15% present value. Just calculate this and keep it in store one. Calculate the number and tell me the value also.
9.56.
Yeah. Okay. Keep it in, store it. Okay.
Yeah.
Second one.
8.317.
8.317.
7.2326.
8.317. No, 1 minute. 8.317. Next one is what?
7.23. Let's keep it till
7.23.
23.
Then next one.
There is 6.28.
Okay. 1 plus 15% raised to, this is 4, this is 5. This is 111. Okay.
Yeah. There is 55.18. So the total is 86.59.
Okay. Okay. This the note that got disappeared. I got a prompt that I have to free up some space. Other sides and store. Okay. Hello.
Yes, sir.
Minute. I think this uh, I have to free up some space from my laptop. But anyways, now can you hear me?
Yes, sir.
Wait. Yeah. So this total comes to 86.59.
Yes.
So now Macaulay duration is equal to Macaulay duration is equal to present value of individual cash flows. First of all, individual divided by 86.59 into 1. Calculate this and keep it in store 1. The next one, so this is the weight you are giving to the time period. Okay. So next weight is second one, 8.317 out of 86.59 into 2. Keep it in store 2. Then third one is, have I missed any number? 1, 2, 3, 4. The fifth one I did not write only. Fifth one is what? 55 something you said, no? The fifth number.
55.18.
Okay. So third one is 7.23 divided by 86.59 into 3. Then fourth one is 6.28 divided by 86.59 into 4. Fifth one is 55.18 divided by 86.59 into 5. Huh. Now you add up all. This is how you are supposed to do. Okay.
There is 4.03.
So we are supposed to suffix with years. 4.03 years. Now that means this is the weighted average time. 4.03. Okay, weighted average time. This is 5. 1, 2, 3, 4. 4.03. So this is the threshold which is neither short term nor long term. Okay, so in this case, so if the interest rate is changing by 1%, so this is the overall time period. See, you think like this. If imagine a zero coupon bond. Acha, tell me if this is a zero coupon bond, 4 year zero coupon bond. Okay, if interest rate changes by 1%, then what will happen to this bond? This bond will change by 4%. Why? Because maturity of your zero coupon bond, maturity of your zero coupon bond is equal to maturity of a zero coupon bond is equal to uh, or Macaulay duration of a zero coupon bond is equal to its maturity. Macaulay duration of a zero coupon bond is equal to maturity of a zero coupon bond. Both are same. Okay, why both are same? Because how much time it will take for you to get your cash here? 4 years. And what is Macaulay duration? Weighted average time for you to get your cash. Is this statement fine? Not
Yes,
understood
sir.
this one?
So
Huh.
basically, we get the cash at the end of the maturity, right? Like we get it in
Yes, yes, yes. That's why that becomes the Macaulay duration. Because
Okay.
what is Macaulay duration? Macaulay duration is the weighted average time for you to get. If I have to receive all this payment in one go, how much time I need to wait for? That is Macaulay duration. If I have to receive all this payment in one go, how much time do I have to wait for? That is
Okay.
Macaulay duration. Okay. So Macaulay duration of a zero coupon bond is equal to maturity of a bond. So in this case, if you think like this is a zero coupon bond, which is for what? 4.03 years. Now in this zero coupon bond, if interest rate is changing by for 1 year, 1%, the impact will be like for 4% impact. Why? Because you have to treat that 4 year as one kind of one product or one bucket or 1 year kind of thing, because there is no cash flow between these, right? There is no cash flow. So if interest rate changes, so here if interest rate changes, if interest rate changes by 1%, okay, if interest rate changes by 1%, if interest rate changes by 1%, the price of the portfolio, the price of the bond will change by, the price of the bond will change by 4% over here. But then we have to take the present value, which becomes the modified duration. This is the time. Now if I, when I say 4%, it will change. What is the present value of that 4%? That present value of that 4% only, we call that as what? Modified duration. So modified duration is equal to Macaulay duration, Macaulay duration divided by 1 plus YTM. Macaulay duration 1 plus YTM. So when we take the present value, so we are treating this zero coupon bond as 1 year bond kind of thing, because it is taking, I mean, there is no other cash flows in between. So overall, it is impacting as per the maturity, 4 years, and we are taking the present value, which is modified duration. Same way here also, so initially I suffixed with years. Now modified duration means what? Modified duration is modified duration is Macaulay duration divided by 1 plus YTM. So what is Macaulay modified duration? It is converting these years into the sensitivity. That is 4%. It is sensitive, and the present value of that 4% is 3.5 something you got, right? Just calculate this. 4.03 divided by 1 plus 15%. How much is it coming to?
3.5046.
3.5046. Okay.
So, like if there's 1% change in YTM, then my return.
Bond is changing by 3.504%. These two formulas are
The
okay now.
bond price, right? Or the return.
The bond price. Okay.
Yeah.
Then next one. Now this modified duration can be found out in other way also. That is called as effective duration. Effective duration. whose formula is V minus minus V plus divided by 2V0 into delta YTM. Okay, so this is like average change based on this change in YTM. Okay, so here again we will take this base case. The base case is 5-year bond, coupon is 11 percentage. Okay, coupon is 11, IY is 15 percentage, future value is 100, present value is 86.59. So now let's say the interest is changing, both the sides. Okay, I'm using the word change. I'm not saying increase or decrease. So when I say change, it can be, let's say 0.5 percentage it is changing. So it can go to 15.5 or it can come to 14.5. So this side is called as V minus. That means value when the interest rate comes down. This side value, if I can, value means present value, is V plus. So now calculate V minus now. That means your IY will be 14.5. Just calculate V minus.
88.1272.
Okay. And right hand side.
This is 85.0921.
Shravani, you also do this and check and let me know if there is a mismatch. Because then only you will get practice.
Yes, it's the same.
Yeah. So now we will plug in the number. This is V0, okay? Now effective duration. V minus is 88.1272 minus V plus is 85.0921 divided by V0 is 86.59 into, so 2 into uh, 2 into YTM. YTM is 0.5 percentage. Okay, so why am I doing 2 into? Because I'm taking 2 times right number here. So 2 times I'm taking YTM changes also. So overall, when you calculate, just calculate all this, what do you
It's
get?
the same thing, 3.50.
Yeah, so you will get the same answer, effective duration as modified duration. So when to use what, depending upon what is the question. If they say change in YTM of the bond, then you should use this one, effective duration. Okay, so it is also called as modified duration. Okay, very interchangeably used terminology. That's why based on the question, you have to figure out whether this is this way or you have to go with um, modified duration. If they speak about Macaulay duration, use this formula. Okay, so till here it is fine. Now this, okay, till here. Now this is also called as this Macaulay, this modified duration or effective duration is called as approximate change in the bond price. It is not the exact change. This word is important. Okay, approximate change in the bond price. Bond price for 1% change uh, in the for 1% change in the interest rates. Okay, approximate change in the bond price for 1% change in the interest rates. Okay, approximate change in the bond price for 1% change in the interest rates. Okay, See why 1% change, can you understand? Because when you divide this, see if I say 10 chocolates distributed to 5 people, what do I get as the answer? 2. 2 means what? 2 means
Per like per person, they are
2
having,
chocolates per person. So
yeah.
when I divide, I will get the value for per. Similarly, here the division is in percent, this YTM. So I will get these are all the changes. So changes for 1%. You understood the logic?
So is it because there was like there were two YTMs, like one was positive and the negative one.
No, that's why I'm multiplying by 2. But even if this would have been, let's say, 0.25% change, then I would have done like this. Here, instead of 0.5, I would have done 0.25% change. But anything I divide by, I will finally get the value for 1 only. Now, instead of 5 people, if I give 10 chocolates to 10 people also, I will get the value for 1%.
So the 1% is to understand the sensitivity, right?
Standardization. Okay, so for 1%, what is the bond price change? So it has been standardized like this. Okay, but it is giving you the approximate value. Why it is giving you the approximate value is because it understands the linear movement. Okay, that means linear movement means, see, remember I give you this graph where I said, see, if this is the price, this is the yield. At 10%, imagine 1000 rupees is the bond price. At 11%, it is 900, because when interest rate went up, bond price should come down. Now at 9%, what should be the bond price? Linearly, if I calculate, it should be 1100, correct?
Right.
Yeah, but practically what happens, the price goes little up. Remember we did this in
Convexity,
the
right?
Convexity, yeah.
that one.
Convexity.
That one only. Now it does not capture the convexity effect. It is just linearly giving me the value. So it is linearly giving me the value. It does not capture convexity effect. So now there is another formula for convexity. Okay. So convexity is equal to, now let me calculate convexity separately. Convexity is equal to V minus plus V plus minus 2V0, okay, divided by V0 into delta YTM square. Okay, now what does this mean? See, V minus is what? 88.1272. 88.1272. Then plus V plus is plus 85.0924. 85.0924 minus 2 into, because twice I am taking, minus 2 times of V0. V0 is 86.59. So 86.59 divided by V0 is 86.59 into delta YTM square. Delta YTM is 0.5 percentage square. Now why it is like this? Because again, this is all giving me the change convexed. Okay, based on why am I squaring it? Because this is the second derivative. Convexity is the second derivative. That means this movement is happening, and then based on this movement, this convexity is happening. So it is like second derivative means, see, say for example, if I say, let's say, if milk's price is going up, okay, milk's price is going up, Then let's say butter's price is going up. Fine. So butter's price is the derivation of milk. Milk price is going up by 1 rupee. Butter's price is also going up by 1 rupee. Okay. Then I can say then butter chicken masalas. This price may go up by 2 rupees now then. This is the second derivative because milk is also going up, butter is also going up, and now they have to increase the price by 2 rupees. So this is the first, butter is the first derivative of milk's price. Butter chicken masala is the second derivative of milk's price. Have you understood this one?
Yes, sir.
Second derivative means because so this is whatever change is happening, finally here more changes are happening here. Okay. So similarly, now the way it is going up here, that much convexity also is going to happen. Okay. So this duration is the first derivative because of the change in interest rates. And convexity is the second derivative because of the change in interest rates. Okay. So that's why I'm squaring it. Okay. To represent that this is the second derivative. Square 2 times changing 0.5 percentage. Now you calculate all this now.
18.2931. I'm getting this.
Okay, fine. 18.2931. So this value changes is 18.2931. Now, what do I understand with this? See, this is convexity. Now, next one, convexity. How do I use all this information?
Modified duration plus convexity, like plus or minus.
See, percentage change in bond price is equal to modified or effective duration, anything you can say. Modified duration into delta YTM plus half of convexity into delta YTM square. So modified duration is what? So this is now we are coming to the point. Finally, what is the change? For let's say 1% interest rate has come down. Assume interest rate has come down. Okay, percentage change in bond price for 0.5 percentage interest rate. Initially, I said it is changing, right? Interest rate. Now I'm saying interest rate is coming down for 0.5 percentage interest rate coming down. Okay. So modified duration is 3.50 into 0.5 percentage. Okay. This is one group. Okay. Plus half of convexity is 18.29831. 18.2931 into delta YTM square. Delta YTM square is 0.5 percentage square. So solve this now. First tell me this part's value. 3.50 into 0.5 percentage.
There is 0.0175.
Plus this number, second part.
So that is 0.000 and then 228,664.
Okay. Now you add these two.
There is 0.01 7728 double 7728
Hmm.
664.
Now you can convert this into percentage. 1.77 percentage. Okay. So this much change will happen. So change means what? See, interest rate is coming down, I said. So what will happen? This much price will go up or down?
Price will go up.
Yeah, because interest rate is coming down.
Yeah.
Okay, so new price will be what? New price will be
101.77.
86.59 was the initial one plus
Yeah.
1.77 because yeah, 1.77 it will go up by.
So
Okay,
1.77 and not percentage, right?
this is 1.77. Okay, 1 minute, let me check that one. Should be percentage. Yeah, it is not percentage, sorry. Change in the bond price. It will change by but here 1 minute, wait. This is converted into percentage only. 1.77 percentage only. This is all percentage. Uh, percentage multiplied by this 86. Achha, no, this is percentage only. Percentage. This is percentage. So this is percentage. Yeah. Now you calculate 86.59 plus 1.11 percentage. Calculate 86.59 plus 1.77 percentage. Percentage only. This is
So 87.603103.
which is here. Otherwise, you will take the entire number, okay, to match it better. So 1.77286664. 1.772866 percentage. Now you try.
88.1226.
Okay, is this fine now? This is the percentage change. So from this much percentage change is happening. This is okay now?
Yes, I understood.
Okay. Now, what if they would have said that the interest rate is going up? Okay, let's see that one. Nothing, just only one change you have to do. Okay.
So we just minus at the end, right, for the price.
Not at the end. We will just do minus in the modified duration formula. I'll tell you that. See,
Okay.
we'll properly do. Okay. Percentage change in bond price. Okay. For 0.5 percentage interest rate going up. Okay, this time. Interest rate going up. So the formula will be minus, just prefix with minus. modified duration into delta YTM. See, basically, this is telling you the change because understand the logic behind the formula. Modified duration means what? For 1% interest, what is the change? Into whatever be the actual change that happened. Okay, modified duration is what? Change for 1% interest rate into whatever change in interest rate that happened. Okay, because the interest rate is going up, so that change is going towards negative side, so I'm writing minus. You understood the logic behind this?
Yes, sir.
Okay, now this change, see, convexity, what happens, convexity actually always convexity always favors the investor. That means convexity, see this is 10 percentage, this is 1000. Convexity, when it was supposed to reach only 1100, convexity increases the price. Similarly, when the interest rate is going up, see, it should be, imagine this much. Convexity, what happens, it reduces. That means it does not allow the price to come to, when the interest goes up, it is supposed to reach to 900. But it will not allow it to reach to 900. It will stop it at, let's say, 950. So convexity always favors the investor. So when the price has to go up, it will exaggerate. When the price has to come down, it will stop before it comes down. It will try to reduce that. So both the sides, it is favoring the investor. Therefore, now this much price is coming down, but convexity will come and save the investor. So what will happen? So if I put minus sign again, then further it will, further changes, more the the price of the bond is coming down. But no, as I said, convexity is favoring the investor. What will happen? Here I will add it, because when I will add, this number power will get reduced. Correct? This number strength will get reduced because here it is minus and I'm adding up. Okay, so, and why do I do half of convexity? Because convexity is happening both the sides here, this as well as this. But practically there is, either the interest rate is going up or down, either going up or down. So that means only half I need practically. Convexity into delta YTM square. So this convexity, as I said, will reduce the strength of Macaulay duration so that the price does not go down much. So minus 3.504 into 0.5 percentage, which came to what? You already calculated here, 1.75 percentage. Okay, so I'll write in percentage, but it is in minus plus. Now, this also you already calculated, right? Yeah, this is already calculated. 0 point, so I can write in percentage, 0.0228664 percentage. 0 point, so I'll write here 0.0228666, 0.0228664 percentage. Now you just add these two. When you add minus 1.75 plus 0.228664, how much it comes to?
It is 1.7271336 negative
Minus 1.7.
271
Then
and then double 36.
percentage, right? Because
Yeah.
it is
No, I
percentage.
didn't put the percentage sign like
But
I didn't
now
do
we
that.
have to suffix with percentage because both the side percentage is there, right?
Yeah.
So now the new price is 86.59 minus 1.7271336 percentage
So
you
that
get.
is 884.86286664.
84 point
8628.
1 minute.
Yeah. 84.86.
84.86.
28664. 28664.
664. So yeah, that's it. This is the new price. Okay. Now, will you be asked to calculate everything from the beginning? No. You will be asked to calculate maybe Macaulay duration, maybe effective duration, maybe convexity, maybe change in bond price, percentage change in bond price. Okay. So based on the situation, you have to calculate. So you take a minute, go through all this, and process all this information in your mind, and let me know if you have any question. Okay. Is it okay? Are you writing when I'm writing? Are you people, or you people will write it later after seeing the video? How, what do you do?
I
Or
write it later usually
Yes,
okay,
yes, same.
you're
because
also
that will
writing
take
later.
time if we write it like.
Okay, 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 fine. Okay, but anyways, you are writing right later on also, because you have to have all these notes with you. Then only later stage it will help you. Okay, okay.
Yes, I make
Or
my notes only.
so later on, okay. Because if you are writing now and if I am going too fast, you are free to stop me. So I'll give you time to write. But if you are writing later, it is fine then. Okay, okay. Then further, so let me take this one step ahead. Then, then this convexity again. This convexity also, there are two ways to calculate. Okay, convexity. See here they said convexity 16.9. We got 18, which is all okay because all those are some decimal stuff will come. Which we will come back to this one again. But before that, because we have done this, where is the convexity again? Just now I saw. Convexity can be calculated in another way also. So I'm just seeing if I can show that also to you now. Duration and convexity. Mhm. Estimate price change with duration and convexity. Okay. Anyways, I'm not getting it. Maybe like whenever I get, I will let you know. Okay, but we'll go in the order only then. See, Macaulay duration. Acha, here it is convexity. This is another way. T into t plus 1 divided by 1 plus r square. So if I calculate this way also, I will get the same convexity. Let me prove that as well. Uh, see, so the convexity that I got here is 18.29. Okay. Yeah. Convexity of a single cash flow at period t. So convexity of cash flow at period t. Okay, so convexity at time 1 is equal to t is 1 into 1 plus 1 1 plus 1 1 plus 1 divided by 1 plus r means YTM only. So r is the YTM. So r square. So for first, so this is, let me write the formula only. T into t plus 1. So for first year it will be 1 into 1 plus 1 divided by 1 plus 15 percentage square. Just calculate this and tell me the value and keep it in store 1.
One point five one two two.
Keep it in store 1. Okay. For second year it will be 2 into 2 plus 1 divided by 1 plus 15 square, 15 percentage square. Calculate.
There is 4.5368.
4.5368.
68. Yeah, 68.
Next one, 3 into 3 plus 1 divided by 1 plus 15 percentage square.
9.0737.
Then 4 into 4 plus 1 divided by 1 plus 15 percentage square.
15.1228. 1228. That is 22.6843.
22.6843. Acha, I made one mistake. Okay, this has to be multiplied with the present value. Okay, this is okay. This has to be not exactly mistake. I can continue from here also. So this is the convexity into I have to multiply with the price. So for first year, what is the price? First year it was So just note down all this amount. This amount. Just note down this amount. Just write it down somewhere.
Yeah, so just a minute.
First year, second year, third year, fourth year, fifth year.
Done.
Now, into what is the first year's value?
Uh, 9.56.
This is the price.
So now I'll save this, right?
Keep it, store it now. Keep storing.
So that is 14.4574.
14 point.
Yeah, 14.45.
1 minute, 1 minute.
So they have also
This is 9 point divided by, this is weight. Achha, this is the weight. Okay, it is like this. Divided by 85 point. What is that total value? 85.59, right? Total value.
86.5.
86.5.
Now you calculate this number. So you basically are giving weight to the convexity. Okay.
So that is 0.1669.
0.1669. Keep it in store one. Second one, what was the value?
8.317.
8.317. Now calculate this, keep it in store.
This is 0.4357. 4357.
Okay. Third one, what was the value?
7.23.
86.59.
Yeah, so this is 0.7576.
Hmm.
6.28. Yeah. So yeah, the answer is 1.0967. $55.18. This is 14.4557.
Now you add up all this.
So this is 16.9128.
Okay. 16.9128, and we got as 18, which is all fine. Okay, these are all decimal stuff only. This is okay. So this is how you can do convexity. So basically this is the convexity. You have given weight to that convexity. So you can think like this is like weighted average convexity kind of thing. You can think like that. Okay, so you can calculate convexity like this as well. Is it okay? This is also fine. Is it okay? Fine.
Yes.
Yeah. Now I'll just stretch little bit more because so that I can finish all in one go here. So we reached it till here, right? Because couple of more points, and even when you practice, when you do all these things at the same time, you will get a correct picture. See, this is 16.91 which they have got. See why they have got and why we have got 18 is this is the difference. You see how much decimal they have used. See the decimal. So that's why we have got 19, 18 something we got, right? Yeah, 18. Because we didn't go for that much decimal. So if we would have gone for that much decimal, we would have also got like this only value. So which is okay. That is fine. Okay. Then next one, estimating price changes with duration and convexity. No, this also we did 88.122. So this is also done. The convexity we calculated, which is here 0.02, 0.0211 percentage, this part. Okay. Then 1.77, so we got 82. This is also done. Another one is this part, last part. For the bond in our previous examples, calculate the money duration. Now, what is money duration? So, money durations. Okay, money durations. Okay. Calculate the money duration and money convexity of your $10 million par position in the bond and estimate the new price of the bond for your 50 basis point decrease in yield. Recall that modified duration of the bond is 3.5 and its convexity is 16.9. Okay, money duration and money convexity. Okay, for money duration and money convexity. Money duration. Okay, so two more concepts: money duration and then money convexity. Money convexity. So money duration, money convexity is annual convexity into full price. Okay. Money duration is annual convexity into full price. Full price of the bond. Bond position. Bond position means whatever number of bonds you have, portfolio's value. Assuming your portfolio has only bond. Money duration means money duration. Money duration money duration is annual modified duration. Okay. Annual modified duration into full price of the bond position. So full price of the bond position means number of bonds also will be taken into factor. Okay. So now how do I calculate these two? Okay, now coming back to the sum. So $10 million par and okay, $10 million par. So we know that annual modified duration, the question is Uh, yeah. See, we calculated for one bond what is the change. This is the change for one bond. Okay. Now, suppose annual modified duration means total money durations I'm going to calculate. So, modified duration is what now? 3.50 into full price of the bond. Full price of the bond is 86.59, correct, is the price right now. So 86.59 into full price of the bond position into the par value is 10 million. So into 10 million. So this will give me total duration of the entire portfolio. Okay, which I'm just directly taking from the book. Okay, because just to avoid all these decimal conflicts. Okay, I hope this step is fine. Is it okay? Just I'm just calculating for the entire bond position. We have done for one bond.
Can you
This
explain this one again?
see, money duration means for duration for my entire portfolio, assuming my portfolio has only bond. So what we have done is duration for one bond. No, this is the change for one bond, correct? 3.50.
Right,
So
yeah.
this is the change for one bonds price. This is the change. Now multiplied by the full position that I have. So this much will be the change. Similarly, this not only duration is going to affect, convexity is also going to affect. So
Yeah.
annual convexity into again same full price. So what is the convexity? Convexity was 16.91. So that 16.91 into full price is again 10 million. Okay, so that comes to uh, what is that? So that comes to acha, here also I need to multiply with 86.59 the price into full prices 86.59 16.91 is for 1 into 86.59. This is for one bond's convexity into total value. Okay, into total value. So this is total convexity. So I have got now total entire portfolio's duration as well as portfolio's convexity. Is this okay? Till here it is fine.
Yes.
Okay. So this total duration of the entire portfolio will come to 30306. That means overall it is like change. Okay, change 30306,983. And here the duration, the convexity is 146. Too big number they have taken. 339 432. Okay. Mm, yeah, fine. Now, if I want to calculate change in the entire portfolio, how will I calculate? So, expected change. Like I was doing that percentage change in bond price, right? Expected change in the entire portfolio. Portfolio means with bond, okay? Entire portfolio will be what? So, what is the formula? Formula is durations, interest is going up or down. They said interest is decrease, they said 50 basis points decrease. That means positive number. Modified duration into delta YTM plus half of convexity into delta YTM square. Okay, so modified duration is this entire duration I'm going to take. This duration. So 30 30,306,983 into delta YTM is what? 0.5 percentage. So it is just I'm kind of, just like in normally in returns, how do we annualize returns? Similarly, we are taking duration for the entire portfolio. Okay, plus half of convexity is 146,339. Because the number is too big, it looks a little scary, but it is just that we are taking it just like returns. I have calculated holding period yield, I'm annualizing it. Similarly, I'm calculating for the entire portfolio into 0.5 percentage square. So when you calculate all this, you will get this number. Just check. First, you calculate left hand side and you see if you are getting this number. Three zero three zero six nine eight three into 0.5 percentage.
151.5349. Like that
This
is
one, right?
maximum.
Yeah,
Yeah.
yeah. So 151 534.
534.915.
Okay, plus. Now calculate all this. Hmm. Ah, how much?
It is 1829.
This number
Yeah,
0.25.
0.25. Right. Yeah.
1829.25. Now
The total
this
is
much.
153,364.158.
Yeah,
364.158.
158. I'm making it 17 to make it
Yeah.
look like book. So this is the change. So if this is the change, expected change. So initially this is the price. How this is the price? So new price will be 86.59. Okay, that 86.59 only they have taken full decimal. I mean 86.59 into 10 million. So 86.59 into 10 million, you check, you will get this number 865913. I mean all decimal they have added 8659. So I'll go with decimal. Okay, 8659,138. Now because interest rate they said it will come down, so this much price will go up. So plus this number. So that will give you no, sorry, not 1 second. This number
Yeah. So that is
153
0.8659, right? So the new price.
8659,138 8 million 8659,138 plus 153,364. 153,364.17. What did you say? Hello.
Yeah. So I think. Yeah.
Okay,
Yeah.
okay,
I
fine,
think I
fine.
made a mistake. I'll check it.
Okay. So this comes to 153,364. One no, this is 153. This is the final answer. New price is 881250. 8812,502. That's it.
So this should
So
be
this
more,
is the
right?
original price.
86.59 into 10 million is like 865 million. That's what I'm getting.
Uh, no, this is percentage.
Okay.
Percentage.
Yeah. So 8,659,000.
Yeah, because this is if the price is 100, it is trading at 86.5. This is the total par value. No?
Okay. Okay.
It is not the number of bonds to directly multiply. It is the par value. The number of bond is actually what 10,000, or this is 10 lakh, right? So number of bond is 10,000. 10,000, no, 1 lakh bonds.
1 lakh.
Yeah, 1 lakh bonds.
1 lakh, okay.
Is it okay now? Fine.
Yes, sir.
Okay.
Can we do it once again tomorrow?
Yeah. You
Means
practice
revise
this.
and then
Yeah, you practice this once. I will redo this all over this again. Okay.
yeah,
But you just see this one only, and do, and then keep your doubts also. Why this is happening, why that is happening. And then when
yeah.
I will redo, then again that gaps will be filled up. Okay. And then it will be fine only. And then it's almost over only. After that, it will not take much time. Maybe in a week's time or 3-4 sessions, we
So,
can even
so
finish up.
after this, can we do economics? Or like, are you
Okay.
planning to take any other subject?
No, fine, we can do economics. Not a
Okay,
problem. Yeah. Okay, fine. So next time again I will do uh, tomorrow, but you just practice this once so that you know that what questions to ask me. Then you will get more clarity. Okay, fine. We'll stop now here.
thank
Okay.
you, sir.
Yeah. Okay.
Bye.
Yes,
Okay.
sir.
Okay.
Thank
Bye.
you, sir.